Okay, let's dive right in. We're going to talk about a single molecule that is, without a doubt, one of the most controversial on Earth. Now, you probably know it as the villain in a massive global health crisis. But what if I told you that to a growing number of scientists, it's a surprising key that could unlock treatments for some of our toughest neurological diseases? This, right here, is the nicotine paradox. And this sums it up perfectly. On one side, you have this idea of nicotine as a sacred medicine, something used in healing ceremonies for centuries, and now being studied for how it can actually protect our brains. And then on the other side, you have the addictive poison, the thing that gets people hooked and drives the worldwide tobacco epidemic. So, this leads us to the central question we're tackling today. How can one single molecule wear two completely different masks? How can it be both a potential healer and a notorious public enemy? To figure this out, we've really got to dig into its incredible story, from ancient history all the way to modern-day neuroscience. So here's our game plan for today. We'll start with how this plant went from being a revered medicine to a global problem. Then we'll unlock the science of what it actually does inside our brains. From there, we'll explore its kind of shocking therapeutic potential, wade into the controversy around immunity and illness, and finally, we'll try to put it all together. Okay, so let's jump back in time a bit, because the way we think about tobacco today as just this bad thing, it's actually a pretty new idea in its very long and complicated history. For literally thousands of years, indigenous cultures in the Americas saw tobacco as a sacred plant. It was a tool for healing, for spiritual ceremonies. When it first got to Europe, people thought it was a miracle cure. I mean, one doctor, Nicholas Menardez, even called it a panacea, claiming it could cure almost anything. The whole villain story, that didn't really kick in until the 20th century when science finally made the undeniable link between smoking tobacco and cancer. And this quote right here, this is everything. The original relationship with this plant was completely different. It was intentional. It was ceremonial, medicinal. It wasn't this casual, habitual thing we see today. And that distinction between its sacred use and its modern misuse is absolutely critical. It turns out the context, the dose, and how you take it, well, that changes everything. Okay, so let's shift gears from history and dive right into the human brain. How does this molecule actually work? What gives it such a powerful hold over us? Well, it all comes down to these things called nicotinic acetylcholine receptors. Let's just call them NACHRs for short. Now, the wild part is, our bodies, our brains, they already have these little docking stations, these locks, built right in. They're essential for everything from moving our muscles to forming memories. And it just so happens that the nicotine molecule fits into these locks perfectly, like a master key. So, nicotine gets into your brain and boom, it pops right into these locks in your brain's reward center. And when it does, it just opens the floodgates for all these feel-good chemicals, especially dopamine. That creates a sense of pleasure and focus, and it trains your brain to say, hey, I liked that, let's do it again. And that's the loop, right? That's how reinforcement and eventually addiction can start. But here's where it gets really interesting. See, there isn't just one kind of lock. There are different types. The alpha-4-beta-2 type, that's the main one involved in that dopamine hit. But there's another major player, the alpha-7 receptor. This one is tied to things like focus and learning. And get this, it helps activate one of the body's main systems for fighting inflammation. And that is a huge clue to nicotine's other hidden side. And activating that specific system? Well, that's the secret sauce behind this whole new, kind of controversial frontier in medicine, looking at nicotine as a potential therapy. So scientists are thinking, what if we could target just those receptors with pure nicotine in a controlled way? And the potential they're seeing is, wow. I mean, we're talking about research into improving focus for people with ADHD, protecting neurons in Parkinson's, and boosting cognitive function in Alzheimer's and schizophrenia. It's just an incredible list of possibilities when the molecule is used with precision. And this, right here, is probably the single most important thing to get from all of this. Ready? Nicotine is not the same thing as tobacco smoke. Cigarette smoke is this nasty, toxic soup of over 7,000 chemicals, including dozens of things that are known to cause cancer. Nicotine is what makes it addictive, for sure, but it's all that other junk, the tar and the toxins from burning tobacco, that does the vast majority of the harm. Separating the molecule from the smoke is key. So let's wade into some really confusing and hotly debated territory now. What is nicotine's role when it comes to fighting off viruses? You've probably seen stories like this floating around online. It's one person's experience, sure, but it's an experience that thousands of other people have reported. They say that since they started using small, daily doses of nicotine, they just don't get sick as often with colds, the flu, you name it. And these stories have kicked off this massive kind of DIY citizen science movement. It's been especially big among people suffering from long COVID. Many of them started experimenting with low-dose nicotine patches, and the results are all over the place. Some people report incredible recoveries, others say it did nothing. It's really pushed formal science to try and catch up. So, okay, we have all these compelling stories from real people, but that leads to the obvious question: what does the hard science, the stuff from controlled lab settings, actually say about all this? Well, here's where the picture gets really complicated. Some of the lab studies, like this one on mice with the flu, seem to say the exact opposite of the anecdotes. In this experiment, nicotine exposure actually led to the mice having more of the virus in their lungs. But, and this is a huge but, mice are not people. And the way they were exposed to nicotine in this study is a world away from someone wearing a tiny low-dose patch. It really just raises more questions. We saw this same confusing picture play out during the COVID-19 pandemic. Early on, there was this hypothesis called the smoker's paradox, the idea that maybe nicotine could help block the virus or calm down the massive inflammation that made people so sick. But let's be crystal clear. The clinical reality is that being a smoker is a massive risk factor for getting severely ill from COVID. But that still doesn't quite answer the original question. What's the deal with pure nicotine, completely separated from all the harms of smoking? The jury's still out. All right, so we've been through the history, the brain science, the medical potential, and the viral confusion. Let's try to pull all these threads together now and see if we can look at this molecule in a totally new way. So here we are, back at those two faces of nicotine, but now we can see it all a bit more clearly, right? On one hand, when it's used with precision, like a scalpel, it can activate these powerful anti-inflammatory and neuroprotective systems in our body. But on the other hand, when it's delivered like a sledgehammer and cigarette smoke, it can drive addiction and mess with our immune system. It's all about precision versus brute force. So let's be absolutely 100% clear on this. The science is settled. Whatever potential good the nicotine molecule might do is completely and totally erased by the devastating harm that comes from smoking. Period. That debate is over. But the scientific conversation about the potential of the nicotine molecule itself, that's really just getting started. Which leaves us with this one big forward-looking question. The real challenge isn't the molecule itself, but how we use it. Can we finally separate this incredibly potent compound from its toxic past to unlock its potential for our neurological and immune health? Honestly, the answer to that question could truly change modern medicine.